and my name is Chidera Onu, and today I'll be talking about power protection. Power protection, why is it important? Why did I choose this topic? The spine of we can all agree, the spine of our national infrastructure is the electric grid, and we can prevent things like blackouts and fires by having more safety precautionary measures in place. Everything we use in the world today runs on some source of power. It could be solar, wind, etc. According to the U.S. Energy Information Administration, Americans used 3.8 trillion kilowatts per hour in 2020, the year 2020. Here we have the different types of power protection. We have cybersecurity, we have backups, we have overload and overcurrent protection, ground fault protection, high voltage transmission networks, low voltage networks, generator sets, distance protection. But before we go into that, we'll talk about, as I like to call it, the new kid on the block, which is the new type of protection being made or being talked about, which is wide area monitoring, also known as WAM. Its main role is to improve the resilience of power systems against stressed conditions. It also offers a real time view of the dynamic behavior of a power system and updates once every cycle. It has a communication network that can contain lag and hiccups in the time that messages are sent. And right here is a picture of what a wide area monitoring would look like. And then we'll go over to the ones that are actually being done. We have cybersecurity. In California, the Public Utilities Commission, also known as CPUC, is a central organization guiding California's extensive cybersecurity program through the last 2 decades. California legislature directed the CPUC to develop programs and lead actions. For example, the CPUC is already engaged in the North American Electric Reliability Corporation Critical Infrastructure Protection, also known as NERC CIP development. We're also a participant in the creation of they were also a participant in the creation of the Urgent Action Cybersecurity Standard 1200 UA 1200. This was a NERC CIP predecessor to the Senate Bill SB 1386 that was passed back in 2002. The smart grid is made up of multiple at-risk components like communication, software, and system integration. And as the topology of the smart grid is decentralized, all elements require a higher level of protection. The communication network is key to striking a balance between the internetworking and data security. Consumers are no longer assumed to be trustworthy. The introduction of smart meters brings challenges in terms of consumers' information privacy. Software is vulnerable, as we all know. It is important to protect SCADA systems from malware, malicious updates. And then we'll talk about backups. Backups, its major role is to remove the affected part of the system to ensure a safe system. It is important to have backup protection. We've heard of different backups. Even in our computers, we have backups, the form of protection that protect our data. But it also has redundancies. As I said, these redundancies ensure that even if there is a failure to any primary protection equipment, the backup protection will allow the system to operate while the main fault is cleared or any damaged equipment is fixed. Some of these redundancies include relays, generators, buses, and fuses. And here we have the overload or overcurrents protection. This requires transformers to safely monitor secondary values and also requires a current transformer. Protective relays monitor current and voltage of the power, a system to detect problems with the power. As the name states, this protects against excessive currents beyond the acceptable current rating of equipment. Circuit breakers, fuses, and overcurrent relays are most commonly used to provide overcurrent protection. The main role of the circuit breakers is to interrupt fault currents and isolate them. Here we have the ground fault protection. This makes of three commonly used detection methods. It uses the zero sequence sensor, also known as the core balance, the ground return, residual ground fault protection. It also makes use of current transformers. A ground fault takes place when one of the system phases come come into direct contact to a ground or to an inductive part that is grounded, such as a metal. This circuit is known to sense any imbalance in the three-phase circuit. Here we have the high voltage transmission networks. This type of protection can be simplified to physical disconnects used to isolate equipment that is experiencing the fault. This level of protection, the main goal is to protect the power plant operations as well as to protect the public. And here we have the low voltage networks. This level of protection takes advantage of grounding systems with fuses and residual current devices. Low voltage network protection involves the use of low voltage circuit breakers to remove ground faults and overcurrent from causing system damage. This serves the largest number of consumers protection of consumers. Protection is a main concern. And here we have generator sets. These are often used in areas not connected to the power grid or places where power outages might occur frequently, like a third world country or like a facility that is just off the grid. And they can be used as main energy sources or a supplementary power source. It has some benefits like automatic loading control, power reliability, and it's also powered by other sources like gas, diesel, natural gas, etc. And here we have distance protection. This is used to detect the voltage and current within a circuit. This system works as an impedance relay. The relay operates when the ratio of voltage and current falls below the set value. During this, the magnitude of the current increases while the voltage at the fault increases. A potential fault will often create voltage sag, changing the ratio of current and voltage. The ratio of the current to the voltage is measured at the point of a potential transformer, and the voltage depends on the distance between the potential transformer and the fault. And in conclusion, from this, we can all agree that power protection is important because being an important part of the world's operations, a little bit of error will be a very disastrous situation. But even with all the protection and security, there are times when issues, will occur. We could have things like blackouts or fire. But I think like a quick response will be something that will help with reducing whatever damage that may have been caused. And we can still agree that there is still more to be done in having better power protection to prevent faults and other disasters. Take for instance the cybersecurity attack on the gas station that is causing limited supply of gas in the East Coast. Thank you.